you? This is Ian. You remember me? It's been a while since I've seen you guys, and I hope you guys are doing well, and you guys are safe and healthy. And I know it's been a stressful time. I've received some good emails from you guys, and keep them coming. And anything I can do to help, you guys just let me know. Okay, you guys are doing well. The assignment 2s have been handed in. I'll have a look at those there in a day or so. And yeah, we're doing great. I'm down in my basement because I've been kicked out of my living room. So if you hear an echo, yeah, that's where it is. And before I begin this class, please have available with you 4 pages that I added there to the week 11 folder. There are 4 pages there, and they're the answers to the questions from within the PowerPoint. And it's not easy for me to, input all this stuff on a computer screen, hence the whole point of being in class, and I can do it on the whiteboard. But what I've done is I printed off, or I made those sheets for you there by my own hand. Try and maybe print off a copy of them so that you can have them there to follow along in the lecture, because they're all marked according to slides. If you don't have a printer or anything available, maybe you can have a split screen, or I do have them available right here. All right. And so it'll be a bit jumpy if you don't have a copy there, but I'll try and do my best, okay? And we're making the best of a ugly situation here, but you guys deserve the best that I can provide. So hopefully there we can get all this done here, okay? So to no further ado, you can pause this if you want to go and print off those copies, do whatever you need to do. But here we are. We are now into the mole. This basically, we have 3 weeks left. We have week 11, which was this past week. We have week 12 and week 13, and then test on 14. Well, after this lecture here, we only have 1 more lecture. And that's the way I've always done this. So we do have kind of a free week where you guys can just practice. Okay, even though the semester has been shortened, that's just the way I've designed this course. So to no further ado, let us go, shall we? The mole. Some of these slides here will seem familiar. And I do it that way because you guys have already seen this picture here. You'll remember there that a mole is just a number, like a dozen. Okay, dozen means 12 eggs, a ream of paper 500, a gross of pencils. Like I've ever used the term, might I have a gross of pencils, please? But anyway, mole just means 6.02 times 10 to the 23 atoms, and it's the relationship there that we use in chemistry to how we count things. Okay, chemically, also known as Avogadro's number. All right. If you hear something in the background, that's one of our 2 cats, and yeah, this is great. Anyway, there are 2 triangle formulas you will have to know. Okay, you've already been exposed to one. And that was the number of moles is equal to grams divided by molar mass. Okay, here there's another one there that you're going to have to know, and the 2 are, there's a bit of a relationship between the 2. For any type of a test, you will not have to memorize these formulas. Well, all of your tests are going to be at home anyway, so they're all going to be open book. In my normal testing, like in the classroom, I would provide these anyway. Okay, and as we said there, 1 mole of donuts is equal to 6.02 times 10 to the 23 atoms. Okay, 1 mole of atoms is equal to this. 1 mole of molecules is equal to 6.02 times 10 to the 23 molecules. 1 mole of ions is equal to that. 1 mole of Snickers bars is that. Okay, and there is an equation that can be used. So the number of moles is equal to the number of atoms or molecules, whichever one you're looking at, divided by Avogadro's number. Okay, you remember how these triangle formulas work. If you're looking for moles, cover it up. So the number of moles is equal to the number of atoms divided by this number. If I'm looking for the number of atoms, cover it up, and that's equal to the number of moles times 6.02 times 10 to the 23. I have lots of stuff here. We'll practice these. Using this formula here, the same one, basically how it's going to work is I'm going to ask you for this, the number of moles, or I'm going to ask you for this, the number of atoms or the number of molecules. Why? Because this number here will never change. So that one there you always have. So let's look at this. Calculate the number of moles in 3.01 times 10 to the 23 atoms of sodium. So we're looking for the number of moles of this amount of atoms. Okay, where are we here? So using this formula here, same one there, the number of moles is equal to the number of atoms or molecules divided by Avogadro's number. So what information did I give you? I gave you the number of atoms, 3.01 times 10 to the 23 divided by 6.02 times 10 to the 23 is equal to 0.5 moles. Now remember that times to the 10, you would just input into your calculator EXP, or some of you will have a times 10 to the button. So to input into your calculator 3.01 EXP 23 divided by 6.02 EXP 23. Okay. Where are we going here now? Let's go back. Calculate the number of atoms in 2.4 moles of sodium. So here I'm looking for the number of atoms. What did I give you? 2.4 moles, and you always have this number. So we have number of atoms is equal to the number of moles times Avogadro's number, 2.4 times that. There we go. Okay. Here is another one here. How many moles of HCl are present in 4.3 times 10 to the 23 atoms? How many moles? Okay. So, right here, number of moles is equal to 4.3 divided by this, and that's how it goes. Feel free to stop the video at any point in time, try it out, work it all out. Counting atoms with mass. Okay, now why scientists have come up with the mole is because there's a relationship between the mass, okay, of an atom and its molar mass. Okay, 1 mole of atoms, okay, is equal to the atomic mass in grams. Okay, so if you had 1 mole of carbon, if you go to the periodic table, find the molar mass or the atomic mass of carbon. You remember that? Atomic mass was 12 AMU. It had 6 protons, 6 neutrons. So 1 atom weighed 12 AMU, atomic mass units. But 1 mole of carbon is equal to the same number in grams. So if you have a mole of carbon, 12 grams. If you have a mole of anything, it's its molar mass, its atomic mass. The bigger of the two numbers, right? The atomic number is the number of protons, it's smaller. The atomic mass is the bigger number, which in this case now is the molar mass. Which is what this slide is saying right here. Hydrogen, okay, atomic mass is one proton. Its molar mass is 1 gram. 1 mole of hydrogen is 1 gram. 1 mole of magnesium, 24 grams. 1 mole of sodium is 23 grams. And you notice here, 1 mole, they all have the same number of atoms. Okay? This is the other formula that you'll have to be able to use. Okay? And it works the same way. Look at this. We've got the number of moles again. So both formulas have moles. Okay? Number of moles is equal to grams, only grams, not kilograms, not anything. Only grams divided by the molar mass, which is just the atomic mass in grams. Okay? And just like the other slide, sorry, I'm jumping around here. This one here you always have. So I'm going to ask for this one or this one. It works the same with this formula. This one here you always have. You have your periodic table. You can tell me the molar mass of sodium or magnesium or phosphorus. Always. This one here is a gimme. So I'm only going to be asking for this one or this one. Okay? Try this one out. Calculate the mass of 2.4 moles of carbon. Okay, so what am I asking for? I'm asking for the mass. So what formula do you know? You have two formulas here, so you're going to have to differentiate. Which formula am I going to use? Well, I only have one that's asking for grams, so I got to choose this formula. What information did I give you? Moles. So you're looking for grams. Grams is equal to moles times molar mass. I gave you moles. You always have molar mass. Okay? And the answer is 29. Was this slide number 11? Right here. So grams is equal to moles times molar mass. 2.4 moles times 12 grams per mole is equal to 28.8, which is 29. Okay? Let us move on, shall we? These are just more questions here. Convert 25 grams of neon gas to moles. Here I gave you grams. What am I asking for? Moles. Okay? I'm asking for moles. Grams divided by molar mass. I gave you grams. You always have the molar mass. Where did you get the molar mass from for neon? You go to your periodic table and you see 20.18. And there you go, 1.23. For the next slide there, okay, it's asking for moles. Okay, let's pop that up here. I gave you moles. All right. And moles, convert 1.42 moles of calcium into grams, and you get this right here. Okay, so try these out. Also in the folder is, what do I got here now? Is it in here? Yes. What do I got here now in class worksheets? Now, I gave you, these are in the folder here, and determine the molar mass, which we'll get there on how to do this. But these are really good, and I want you to try these out. All right, it's one skill after another, and it's just repetition. That's all math is, but we'll get there. Which of these is not correct? The mass of one atom of carbon, the mass of one atom of carbon is 12.01. No, that seems pretty correct. The mass of 1 mole of carbon is 12 grams. No, that's correct. Avogadro's number of atoms has a mass of 12 AMU. No, It doesn't. Okay, so don't even need to look at D, but Avogadro's number of atoms has a mass of 12 atoms, or 12 grams. So this is what we're talking about here with carbon. What do we got here? How many moles of atoms are in 3.52 grams of aluminum? So, like on a testing situation, like the final test there, it's going to be mashed potatoes. You never know which question's going to be coming next. So you've got to kind of reboot every single time you finish a question and move on to the next one. So how I want you to do this, every single question, okay, what is he asking me for? How many moles of atoms? Okay, so I have two formulas that have moles. All right? And what information? Oh, there's my dog. Harley. Beagles. Come on, get out of here. Actually, no, you can't be up here, because you're going to get after the cats. Go on, out.